Hi everyone, today we're going to talk about two very important concepts in physics, impulse and momentum. You've probably heard these words before, maybe in sports or everyday conversation, like that player has a lot of momentum. But in physics, these terms have precise meanings, and they help us explain how objects move and interact. Let's break them down step by step. First, let's talk about momentum. In physics, momentum is defined as an object's mass multiplied by velocity. We use the letter P to represent momentum, so the formula is P equals to the mass times velocity. Since velocity is a vector, which means it has direction, momentum is also a vector, which means it has both magnitude and direction. Now, imagine a bowling ball rolling down an alley. The faster it rolls, the heavier it is. The harder it will be to stop. That's momentum. It's measured in kilogram meters per second. Now, think of two objects, a boulder rolling downhill and a tiny hailstone falling from the sky. The boulder has a lot of momentum because of its large mass, while the hailstone might have momentum because of its high speed. Both factors, mass and velocity, plays a role. Now, let's look at a car. When a car is moving, it has momentum equal to its mass times velocity. But what happens when you slam on the brakes to stop the car? The car skids at a certain distance because it takes force applied over time to reduce its momentum to zero. I have a question for you. Do you think a heavier car moving at the same speed as a lighter car will take longer to stop? The answer is yes. The heavier car has more momentum, so it needs more force or more time to come to a stop. The formula for impulse is the force times the time interval during which the force acts. So it is measured in newtons times seconds and is directly related to the change in momentum of an object. This relationship is known as the impulse-momentum theorem, where F is the change of the force applied, delta t is the time interval during which the force acts, and delta p is the change in momentum of the object. Here's an example. Imagine you're pushing a heavy box. If you push gently for a long time, the box will eventually move. Or you can give it a strong, quick push to achieve the same effect. In both cases, you're applying an impulse. But the force and time are different. Now, let's talk about some real-time scenarios where impulse and momentum matter. First, car crashes. Well, in a crash, a car's momentum changes suddenly. Airbags and crumple zones are designed to increase the time of the impact, reducing the force on passengers. Next, trampolines. If you fall onto the ground, the impact is instant and it hurts. But if you fall onto a trampoline, it stretches, spreading the impact over time and reducing the force onto your body. Next, baseball. Baseball players are taught to swing through the ball. Why? Because keeping the ball in contact with the ball for a longer time increases the impulse, giving the ball more momentum. Finally, let's touch on the law of conservation of momentum. This law states that in a closed system, the total momentum before and after a collision remains the same. For example, on a pool table, when one ball hits another, momentum is transferred. The first ball might stop, but its momentum is passed on to the second ball. This demonstrates the conservation of momentum. So, to summarize this video, momentum is mass times velocity. Impulse is the force applied over time, which changes momentum. And momentum is always conserved in a closed system. These principles help us understand motion in the world around us, from driving cars to playing sports. So if you enjoyed this tutorial, don't forget to like, subscribe, and share. Thanks for watching, and I'll see you in the next video.